Welcome everyone. This one is a little bit more different because I'm not really looking at Ableton. I've been trying to learn how to live code, and one of the things that I've done, I'll just clean out some of this stuff here, is to sort of try and model Monome Norns' awake dual sequencer, but model it using Sonic Pi. Now, I'm not guaranteeing that the code I'm actually doing is necessarily correct, but it seems to work. I'm not really a coder. But what you will, the coding, or the code that I'm using here, is that there's a link to my GitHub. I've done a little GitHub with some fragments of code and ideas and stuff. So there are things like matrix sequences and various other things. So you might find those interesting. I don't know. But basically what we have here in terms of the awake sequencer is you've got two sequencers. It's a dual sequencer, but you only ever hear the output of the main sequencer, and therefore the second sequencer essentially adds new notes or new values to whatever their current value is at the playhead. That's basically the idea. So if you have a value, so if you're dealing with numbers, so if you have MIDI C4, which is 60, and the dual sequencer has 0 underneath it, then the total value is 60. Whereas if the dual sequencer had 2, then it would be 60 plus 2, 62. If it was, like a negative number, like -3, 60 minus, so it'd be 57. And so the default synth is one that's called beep, which is kind of a pulse wavy, squarey type sort of thing. You have BPM, and then I've defined the scale. So the scale can change. So we'll go through the different sorts of scales, and the number of octaves for the scale to be generated across is 3 octaves. And then those 3 octaves are kind of addressed by a combination of these two parts here. You've got the main notes sequencer, which is this one here, and this is just a sequence of numbers between 1 to 7. So it goes from 0 up to 7, which is your 8 notes of your scale, assuming it's got 8 notes. And then you have the short one, which is basically the second sequencer, which adds. So at step 1, where you hear 1 plus 5, you actually get the output of 6, whatever that is. So the way that I've kind of programmed this is that it addresses a position in the scale. So it's scale position 6, scale position 0, right? That's kind of what's going on here. We don't worry about the counters, and the main part is really just the play part that's here. So let me play it. Hopefully it's not too loud. So you use Command R to put it into play. So in a live loop, every time it cycles around, it generates a tick, which means if the tick starts at 0, the next time round it goes to 1, 2, 3. So you can access that to look at your list. So as I've got a list of values, I've got 3 different types of list. One list is the scale, which is this one here. And then I've got 2 lists, which are the dual sequencer. The upper sequencer, which is the notes, and the lower sequencer, which is the note short. So at the moment, the values are 5 and 6. Here, notes short now is at 0, and because it's at 0, we should actually just hear the same 8 notes going past. Let's have a listen. So that's what we have there. So the moment that we put a new value in, so I'm going to put 7 in there, you'll also probably note, you may or may not be able to see it, I don't know, but this lower set of items is actually only 7. It only has 7 in it. 1, 2, 3, 4, 5, 6, 7. Whereas the above one, the one above it, has 8. 1, 2, 3, 4, 5, 6, 7, 8. Which means you already get a kind of a phasing effect. So let me first of all change the lower one to 8. So now they're 8 and 8. So what should happen is that 7 should occur in the same place all the time. So when I remove the size of the list by 1, we get a shifting value. To my mind, it's way more beautiful, right? It's a lovely sound. So we can have 7 and 6, one higher and one lower in positions 1 and 2. Let's have a listen. Let's try one here, which is 5, lower figure, 5 going up to 7. Which is nice, you know. And of course you can move around and change this into any number of different values. Let's try, so the lower list, the lower sequencer is going to be in 3s, and the upper one is still going to be in 8. So you can get lots of variations going on. Let me just take that one out there. Fantastic. So you've got lots of different synth engines here. Let's do... So you can see here the number of synth engines you can have. It's quite a large amount, and they're based around the ones from Super Collider. So the one that I'm using here is FM. I think it's a really good one, and it's slightly different, at least in my understanding of it, from, say, using Operator. It's a different kind of vibe, but I do like it. You've got a number of things whereby you can control the envelope curve. In fact, let's hear it without any of the other stuff in there right now. That's a different sound. So let's try it with the envelope curve set to 1. Now there are a number of envelope curves, and if I remember them off the top of my head, there's 2. So 2 is a very percussive one. So you can see that you'll go, hang on a minute, where's my sound gone? I think there's a 3. Now some of them don't feel like they have much differences, but there are differences, and we'll look at how those differences can be sort of made more obvious with some of the other instructions. 6 is one of my favourite ones. It's much more percussive, a bit more like a low pass gate. 6 and 7, that's similar-ish. 7 is just a bit shorter. So if you want a tighter kind of low pass gatey type sound, then 6 is definitely, 6 and 7 are definitely really good ones. 1 gives you much more generic, and 2 gives you much more of a percussive. 3, similar to 1, 4 if I remember correctly. The one it doesn't have is 5. 5 generates a crash, so this is what happens when you use something that you're not supposed to use. You get a nice big pink warning at the bottom there. So you can have 1, 2, 3, 4, 6, 7. Not quite sure why 5 isn't there, but I'm not going to ask. And you can see here at the bottom where it says one of the following values, and then it puts it in some brackets, 1, 2, 3, 4, 6, 7. And it tells you that it got 5. And at least in this video, I'm able to show you that I can make it crash properly with full understanding of all the consequences. So let's keep it at 1. And then the next one is that when you've put the comma in, you'll find a number of other parameters that come with this FM synth. They're quite a lot. Got things like attack and decay and so on. So I used one that was depth. So let's have a listen to that one. Now for this one, we're moving between, this rand is generate a random number within a range of values that you preset. So this is 0.1 to 0.8. And basically you're asking each loop that it goes around to essentially put in a new random number. Now, the last one that we have here is the divisor. So the divisor is kind of like the index for the modulator. So at the moment what we're listening to is the carrier, and now once we put the divisor in, we'll actually also hear the modulator moving around. So this is the index. So I've kind of set this as a between 0 to -2, 1, 0, -1, and then this dot choose, which means that every cycle you tell the live loop to just pick one. It's kind of like a random sort of offering, but it's within a defined set of parameters. Let's have a listen to this. So let's listen to it with the divisor set to 0. Right? So you can hear the difference here. Let's change it to 1. You can hear it brighter. Let's do -1. It's a little bit duller. Let's do -2. You can hear the octave below now. Do it 2, so we should hear an octave above. 3. Now it starts to get a bit more inharmonic, right? So let's try it with the envelope curve of 6. Right? So that's why you need these envelope curves. We can't have the same kind of size of envelope. We actually want something that's a bit more exponential. Let's try it with 7. Tighter, right? So it's 4. Let's do -4. 12. Let's jump a bit. It's still in there. 12 above. So you can hear it's sort of really modulating it at a very sort of extreme kind of index point, right? 1. Right. So this divisor, this code that I have here, is essentially just selecting through a number of already predetermined kind of modulation index points, right? And then you can add as many as you want, really. I mean, you know, if we wanted the -12 to be in there, then it will come up. So there you go. So I'm going to do a few more of these, not too many. I don't think I'm a great live coder really, but I like using it. And I've been using it quite a lot with my controller. Using it quite a lot with my controller, 16N, so I've been using it with that. Being able to change values in real time, which is good. And I've also been using it with Ableton. So being able to send either MIDI controllers or notes or whatever else coming out Sonic Pi into Ableton that works well. And I've also got some stuff that comes from Ableton to Sonic Pi. So those are all kind of like interesting developments, and I'm going to go through a few of those. If you've liked this, please remember to like and subscribe. There are links in the description below that are going to have links both to my GitHub with this code in it, and of course to Sonic Pi, and also to Sam's tutorials, which are a good place to start from. I'm not going to be doing tutorials in this sense, other than working through some ideas. So until next time, thank you very much. Remember to like and subscribe.